Hello guys, welcome to our first video lesson. Should be kind of exciting. Hopefully you took your notebooks home with you and you prepped for that, because I don't think I said to do it. If not, just write your notes somewhere on notebook paper, that way you could add it to your notebook later. And be sure to make sure you're doing it, because you got to submit those on EDSB, so you want to make sure you're writing it down. What's great about this actually is that it kind of works a little bit better for you, I think, because I'm saying the notes and I don't have to kind of go at any pace other than just go. And if you find yourself stuck, feel free to pause, look at what you're writing, write it down first, then listen to me, rewind it, keep going until you understand it. Of course, if you have any questions, please send them to me. I will answer them and do my best to make it make sense. So today we're going to start on page 27, which is ellipses. So we started parabolas before we went on spring break, and parabolas were pretty straightforward. I mean, we knew what a parabola was, but the idea behind the conic section of a parabola is that you had a point called the focus and a line underneath that called the directrix. Or if the parabola is upside down, it would be vice versa, focus and then directrix up top, and obviously the left and right horizontal combinations. The point being is that any point that you picked on that parabola was equidistant from the vertex, from the focus to the directrix. Well, today, when we're talking about ellipses, it's kind of similar, but also kind of not at all similar. But the idea kind of still stands there. So what happens if you have an ellipse? An ellipse is what we might call an oval. It's just like a circle that's been stretched out. It has two foci. Notice I called them foci. They're not focuses. They're foci if there's two of them. It means the same thing, though. It's a focus. Focus 1, focus 2, or the focus on the left, focus on the right. Of course, like our parabolas, you could turn this, and then I would have a focus on the top and a focus on the bottom. Just depends on how it's oriented. The one that I've drawn for you here has the focus, the foci on the left and the right. So I've drawn a horizontal ellipse. So what's going to happen is if you have those two foci, if you pick any point on the ellipse, the distance that you're going to find between those two foci is always the same as the distance if you were to add those two distances together to any other point. Let me make that a little bit more sense. If you look at my picture, I know it's kind of hard to tell the pink and the blue, but there's a pink point that I put on top. If you look, the distance that I made from that pink point going down to the foci on the left, that distance I represented as D1. And if you look at that point going kind of straight down, a little bit off than straight down, but going straight down to the foci on the right, you'll notice that that point is D2. Well, if I take D1 and add them to D2, what happens is if I pick another point, say in this case the blue one, the distance from the blue point to the foci on the left is D3, and the distance from the blue point to the foci on the right is D4. Well, if I add D3 and D4 together, it's going to equal D1 and D2. And that would reason for every other point. If you made another point off on the right-hand side and called the distance to the foci on the left D5 and the distance to the foci on the right D6, D5 plus D6 would equal the same things, and D7 and D8. And if you kept going, any point you pick is going to equal that same number that we'd refer to as the constant. That's what makes it an ellipse, is that any point on that ellipse on the outside is going to be the same distance from the sum of the two foci. So with that, let's kind of look at one setup. So give me a sec. Bear with me. I know it's a little bit weird. Hold on. Gone. Okay, I have this picture here, and I'm going to let you draw this picture in just a minute, but just bear with me for a second. What's going to happen right here is we have a couple representations. The first one, the distance from here, which we'd call the vertex, to the center of the ellipse, that length would be referred to as A in this problem. And what's important to know is that the distance from the center to the other side is equal. So that would also be representing A. If we go from the top here down, we would call that length B. So from the center to the vertex on top or the vertex on the bottom is B. Notice then we have 1, 2, 3, 4 vertices. That's what happens in ellipse, 4 vertices. The last distance we got to look at is from the center to the focus. This center to this focus right here will be C, which also goes on the focus on the other side. The distance from this focus to the center is also equal. So there's those two C's on this problem. But here's what I really want to make sure you saw in this, because there's something super important that comes up that kind of goes against some of the things that we're used to. It doesn't really, but it looks like it does. Let's say that I use what we just talked about. Let me choose this point up here, okay? if I choose this point and I connect it to the focus over here, well, we already used A, B, and C, so let's call this D, okay? Well, the distance from this point to this focus would also be D. The reason they're both D is because I purposely picked the point right here at the top, which is straight up above here. And so because it's straight up above the center, then the distance from here to this focus and here to this focus is going to be the same. So what we're going to call this is we're going to call this focus distance, or just F, right? That's my constant F. And we just talked about if I add these together, D plus D, it gives me the focus distance, which I could just simplify to 2D, okay? So the distance from that point to the two focuses added together, the two foci added together, is 2D. Well, let me choose this point over here. Let's go ahead and choose this point over here. Colors, I want different colors. Let's see if, boom. Okay, so let's choose this point right here, okay? Well, this point's a little bit more tough, but we know that the distance between it and both foci is the same. I said foci is the same as the distance between this point and the two foci. Well, this one's a little bit harder, but let's figure it out. Let's start with this focus on the right-hand side. Well, that one's easy because it's taking from here to here is A, and here to here is C. So the first distance is A plus C. And I'm going to add that to the distance to the second focus, which is this one on the left. And that one is a little bit tougher, but I mean, we know the distance from here to the center is A, and from the center to this little spot is C. Well, then all that's happening is we're taking A and getting rid of this part C from it. So we're going to call that one A minus C. And I can simplify that pretty easily. A plus A is going to give me 2A, and C plus negative C is going to cancel out. Since these are both equal to F, they're both the distance from the focuses, the foci, well then 2D has to be equal to 2A, which means D is equal to A. That's super important because notice that if I go and take some of this off here, let's see if I can get that to work. Maybe not. Maybe not. Oh, I got some of it to work. Look at me learning this new technology. Okay. Since we can now justify that this length right here, which we said was D, is also A, what I know then is that this right triangle right here, we have B, C, and A. So B squared plus C squared equals A squared. But hold on, that doesn't make sense, right? It's A squared plus B squared equals C squared. Be mindful that what's happening here is the A, B, and C that you would see in a right triangle is not the same A, B, and C that's happening here, right? In this problem, A and B, like in a regular right triangle, A and B would be the two legs. Well, in this problem, the legs are B and C. The hypotenuse is A instead of C. So it's still the same formula, it just looks a little weird. So be mindful of that. It is the length vertically up top, the length horizontally to the focus, and that's equal to the length horizontally from the center to the outside. So just be mindful of that. With ellipses, you have to use B squared plus C squared equals A squared, right? All right, so let's switch this back over here. And that gives you this piece right there. So a couple important things to make note of there. We said it's B squared plus C squared equals A squared. I showed you why. The length all the way across, the longest length of the ellipse, we call that the major axis, which would be equal to 2A, the A on the left-hand side and the A on the right-hand side. So that would be the major axis, both those A's. The minor axis would be the short one. You've got a B and a B, so it would be 2B. All right, and then 2C is the distance between the foci. So just remember that. The major axis, you have to cut it in half to get A. The minor axis, you have to cut it in half to get B. And if they give you the distance between the two foci, which they probably won't, they'll probably give you the distance from the foci to the center. You would just know that that has to be C. Okay, so let's take a look at our formula first before we go on. So the standard form of an ellipse looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. Remember we said with parabolas, same thing. H and k are your x and y of your parabola. Same thing happens here, is that h is going to be the x value, and k is going to be the y value of the vertex of your parabola, which is going to be that little center point in the middle. A squared and b squared represent your major and minor axis. So your major axis is going to be represented by the a squared. So you can square root that to get a, and then double it to get the major axis. B squared will be the smaller one, and that will be your minor axis. Again, square root it, cut it in half, or sorry, double it, and you'll get the minor axis. Make a note here that a squared and b squared can switch places. If the biggest number is under the y, then you know that the minor or the major axis is going vertically. So your ellipse, instead of going like this, is going to go like that. So whichever number is bigger, whichever variable it's under. If it's under the x, it makes a horizontal. If it's under the y, it makes a vertical. So just be mindful of that. Okay, so we are going to look at 2 examples today. Get myself back where I need to go. Okay. Delete. Okay, so taking a look at this then, example 2. Or sorry, 1. We're not 2 yet. Oh no, that's not what I tried to do. Technology. Technology's going to beat me, guys. Pew. Pew. There we go. Okay. Example 1. I'll put up my nice version of this too at the end of the video so you can copy it from there. But use this moment to maybe follow along. Okay, so what happens in example 1 is I want to write the ellipse, whoa, where did I go? In standard form. Okay, and I'm given a couple things. I'm given that the foci is 0, 1, and I have another one at 4, 1. Okay, and I have a major axis, and the major axis is equal to 6 units. Well, all those things are going to play an important role here. The first role that I need to figure out, let me go ahead and put a different color on here to make it a little bit nicer so we can see some things that we're doing. Okay. No. Okay. So the first thing I want to do is I need to find where the center is, where that vertex is, right? So the center is pretty easy to find. We're just going to use the midpoint formula. So I'm going to take those 2 points that I have up there, 0, 1, and 4, 1, and I'm going to find the midpoint of them. If you don't remember the midpoint formula, it's pretty easy. You add the x's together and divide by 2, and then add the y's together and divide by 2. So what I'm going to end up with is 0 plus 4 over 2, and 1 plus 1 over 2. It's essentially you're finding the average of the 2 points. Well, 0 and 4 gives me 4, and 4 divided by 2 is 2. And 1 plus 1 is 2. 2 divided by 2 is 1. And these two numbers represent my center or my vertex. They also represent h and k, which are going to be super important to our formula, right? We now know that the B formula is going to have x minus 2 up top and y minus 1 up top. So it gets us a good start. So a couple other things we need to find then in order to put this formula together. Let me get a different color again here. And we'll jump over to pink. Look, I'm going to stick with pink and blue for my colors. I love them. Okay, so the first thing we got to find is we got to find our A. Well, that's really easy, right? Because A is the major axis. They told me the major axis is 6. Well, if the major axis is 6, remember that's 2A. So we just take 6 and divide it by 2. And what we know then is that our ellipse from the center to the from our center to our along our major axis is 3 units long. We have to figure out whether or not it's going to be a horizontal or a vertical ellipse. We're getting there. Next, I want to figure out what I could do next. And the one that I could do next is easily C. Remember, we said C is the distance from the foci to the center. I know the center is 2, 1. I know the foci is 0, 1, or 4, 1. Well, think about that then. How far is 0, 1 from 2, 1? Well, the 1s are lined up. The 0 and the 2 are 2 apart. 2 is also 2 away from 4, so you can see it's equidistant from both these. So what I know is my C is equal to 2. I'm in really good shape now. I could take those two things, and actually, I knew if it was horizontal or vertical already. That was dumb of me to not point that out, right? If the foci is at 0, 1 and 4, 1, well, those 2 points line up in a horizontal line. So I have a horizontal ellipse, meaning 3 is definitely the longest side. So that's going to be my horizontal distance. My next distance to find is going to be, hold on, the dog wants out. Gone. Okay. The next thing I got to find is I got to figure out what b is. And that's where I'm going to go back to that formula we talked about at the beginning. It's the Pythagorean theorem, but it's a little bit weird because a is actually the hypotenuse in this problem, right? So it's going to be b squared plus c squared equals a squared. I know that my b is unknown. I know that my c is 2. And I know that my a is 3. So I'm going to get 4, 9, subtract that. I get b squared equals 5. And to be honest with you, I'm going to stop right there. That'll make sense in a second. Right, so now that we've established that we're going to do a horizontal ellipse, right? So get my last color here. We can go ahead and we can set everything up now. So I'm going to come over here and I'm going to say that my beginning part, which we knew from the beginning was x minus 2 squared, and then plus y minus 1 squared. Again, that came from here and here. You plug it into the x minus h, y minus k. So those positive numbers look negative down here now. And then I'm going to put those over something. That's where we put our a and our b. Again, it's important to decide, well, which direction is this going? If it was going vertically, I would put a underneath the y value. If it's going horizontally, I'll put a underneath the x value because it's going to go under the one that's the biggest. Well, in this case, because it's a horizontal, because my foci are lined up in a horizontal line, I know that x is going to be the bigger one. So I'm going to put a underneath that. But it's not going to be 3. It's going to be a squared, so it's going to be 9. So I took this number right here, I squared it, and I got 9. And that's the number I put in over here. Lastly, I go over here and do my y value. My b goes under here, but it's b squared. Well, look, I already know what b squared is. It's 5. If I had square rooted, I would have had a decimal. I'd have to re-square it there. Be a pain. I just put my 5 down there. And all my ellipses equal 1, so I'm going to set it equal to 1. And that is my answer. Cool, right? All right. Going on and doing my last example. And again, like I said, I will put this up in just a minute. Hold on, someone's calling me. Let me tell them I'm recording, and I will call them back. Okay, doing my second example on here. Second example is a little bit tougher, but still not horribly tough. Okay, clear, clear, done. Look at that, gone like that. Okay, so example 2. Example 2 here says, I don't know why I keep doing that. I don't know what I'm doing. There's all these like hotkeys on this little pad thing that I bought, and I don't know them. Okay, example 2. Okay, example 2 says, what are the vertices and foci of the given equation? The given equation is going to be x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Let me make that y a little bit better. There we go. Okay, so we did this with the parabolas. Remember, it's that completing the square thing, which I think most of you are going to be okay with, right? It's one of those things that we kind of forget how to do, but once you refresh yourself on it, it's like, oh yeah, that's not that bad. Okay, so what we're going to start by doing is I need to go through first, and I need to complete the square with all these parts. So I got to reorganize the formula. So what I'm going to do is I'm going to put my x's together, so x squared plus 6x plus a blank to complete the square in. And then I'm going to have my y. So I'm going to do plus 4y squared minus 8y plus a blank to complete the square in equals, and then I'm going to take this 9 and I'm going to move it to the other side by subtracting it. So it equals -9, right? So filling in these spots here then, we are going to, I need to make some like favorite pens here to make my life easier so I don't have to keep clicking on that. Okay, so to fill in these blanks, what we're going to have to do is we're going to take this number, remember this number right here, and we're going to cut it in half. So 6 divided by 2 is going to equal 3. And then I'm going to put a square around it, and I'm going to square it. And 3 squared gives me 9, so I'm going to put a 9 in this blank. If I add something to this side, it is very important. I forgot to put the blanks over here. But you have to maintain balance. So if I added a 9 over here, I have to add a 9 over here, and the formula stays balanced. This creates a problem. I got a 4 and an 8, and ooh. So what I'm going to do is I'm going to actually factor out a GCF there. Y squared minus 2y plus blank. Important to know, you cannot complete the square if there's a 1, if there's not a 1 in front of the y squared term or the x squared term. So you always got to factor out whatever that is to make it so it's a 1 in front. So now I can go ahead and do it. Negative 2 divided by 2 gives me negative 1. Square that number, and then square that number, and I get positive 1. So I put a positive 1 here. When I go over here to add, though, you got to be careful. If you just put a 1, you've done it wrong. Because we didn't add a 1 to the side. When I redistribute this 4, we added a 4 times 1 to that side. So you always have to take whatever this number is and multiply it by whatever you factored out. Then I can do all my stuff over there. Okay, let me go back up here, switch back to blue. We did the completing the square step. Now it's just a factoring problem. So over here I'm going to factor two things that add up to make 9 and, multiply to make 9 but add up to make 6 is whatever you put in that box right there. So it's going to factor into x plus 3 times x plus 3, which we'll rewrite as x plus 3 squared. And then I'll add that over here. Over here, when I factor this out, we're going to have a 4 on the outside. And we know it's going to factor into y minus 1, because negative 1 times negative 1 will make positive 1. Negative 1 plus negative 1 is negative 2. So y minus 1 squared. And it equals on this side, we add this together. Negative 9 plus 9 is 0, plus 4 can give me 4. The last step to getting this in its standard form is that I need to go ahead and simplify this last side the rest of the way. So what happens is, remember that our ellipse has to equal 1 on this side. So we're going to divide this by itself to make it equal 1. So if I divide that by 4, I'm going to divide this by 4, and I'm going to divide this by 4. And now you're starting to see that ellipse come together, right? These cancel out, and ultimately I end up with x plus 3 squared over 4 plus y minus 1 squared over 1 equals 1. That gives me everything I need to do this problem now. I can find my foci, I can find my vertices. I know now, and let me get my last color here just to signify that we're finding our answer. Going back to that purple. Bloop, bloop. Okay, so we're going to take the center. The center, remember, is h and k. H is always with the x, so be mindful that if these got switched somehow, this is going to be your h right here. Well, since it says positive 3, I know that the center was originally the opposite, negative 3. And since this says negative 1, I know that originally the y value was a positive 1. Okay, so that's my center. My a and b, which come from here, since this is a squared, we know that a has to equal the square root of that, so it equals 2. And since this is b squared, I know that b equals the square root of that, which is 1. So what it tells me is that along the x-axis, my foci are each 2 units away from there. So foci. My foci are 2 units. Sorry, that is incorrect. The vertexes are 2 units away, right? Vertices, correct myself. The vertices along the horizontal axis are a distances away. So if I take that x-axis and I go negative 2 more to the left, well, it's going to become negative 5. And if I go 2 units to the right, it's going to become negative 1. So there's my vertices on the horizontal axis. Now to do my vertical vertices. Remember, it's going to have 4 whole vertices here. Well, since my b is only 1, it's going to just be 1 up and 1 down. So I'm going to keep the negative 3. If I go 1 up, we're going to be at negative 3, 2. And if I go 1 down, we're going to be at negative 3, 0. So those are all my vertices. The focus, or the foci, those end up being slightly different because I got to figure out what C is to do that problem. I have A, I have B, I don't have C. So we're going to use our formula for this, which we know is not A squared plus B squared equals C squared. It's B squared plus c squared equals a squared. So b squared we already know is 1. A squared we already know is 4, which means c squared is ultimately going to equal 3, which goes to reason that c is equal to the square root of 3. Okay, so now I can go ahead and do the foci. Well, that's just the work over here. Let's put my answers over here. Okay, so when I go to do my, let me make sure that's not, I'm worried that my head might be in your way when I do that. Okay, going over here then, pretty easy. The foci are on. We know that since the major axis is horizontal, the foci are also on the horizontal axis. So what I'm going to do is for my foci, I'm going to take that horizontal, or that x value, and the first I'm going to add square root of 3 of it. And for the second one, I'm going to subtract the square root of 3 from it. Notice the y value didn't change because it's lined up on that horizontal axis. So those would be your two foci. If you wanted to do the math and actually figure it out, you could. If they asked you to leave it exact like that, they would. I can tell you on your exam if those happen. It's all exact because it's a non-calculator portion of your exam to do these. So you would just leave it like that for your foci. And that's example 2. So bringing us back over here to the actual page of notes. That's what those two examples look like in my nice, neat, beautiful, killer coordinated handwriting. So hopefully you didn't write those down earlier. All right, I hope that makes a little bit of sense. Please, whatever questions you have, send them to me. I know this is a huge topic. Ellipses are tough. I rewrote these notes 3 times because I haven't touched ellipses since high school. And so I did these notes once, and I was like, I don't even understand what I wrote, and I threw them away. And I did the notes again, and I was like, okay, I get it now, but my notes don't make a lot of sense. So I did it a 3rd time, and this made sense. So hopefully you can work through that. Hopefully that all works out for you, and I will see you in the next video lesson. Bye!